So you get this fractal multiverse, ever growing exponentially fast. And really bizarrely, those theories have some support from the cosmic microwave background. They're theories that explain the structures we see. I should just underline the fact that this is speculative in a sense, but it's relatively mainstream. What one of my colleagues noticed, and some physicists have noticed, is if you were some kind of omnipotent deity programmer and you wanted to run what's called a Monte Carlo simulation to say, well, I'll vary the strength of gravity in one universe and vary the mass of the electron in another one and vary these physical constants and see what happens, then this is probably the kind of thing you'd do. This is what it would kind of look like. So that you can make an argument that the universe, in some sense, looks like one of these kind of so-called Monte Carlo simulations, because it gives you the possibility of generating every possible number of different ratios of the strengths of the forces of nature and all these things. So and what is fun and interesting, though, is that the wind all the way back, the inflationary cosmology bit is probably the most widely accepted theory at the moment for how the universe got to be the way it is. And it does lend itself to this idea that there may be a multiverse, and it may be that in each different pocket universe, if you like, you can have different physical constants, and that's how you get the heavy elements that make up our bodies. And so all those things you either try and find an explanation for why the laws of nature are the way they are, or you go to one of these multiverse theories and say, well, actually, every possibility occurs in nature. And then we shouldn't be surprised that we live in a universe that seems fine-tuned for life, seems perfect for us to exist in, because every possible combination of the laws of nature exists somewhere.